So when I'm teaching this in person, I ask my students to ponder the question, how does a vertical shift of a function affect its derivative? And I don't want people to shout it out because some people will know automatically, like immediately, and some people, it'll take a minute to think about it. So pause and think about it. And then, once you know what it is, you can shout out your answer. We can take a look at how each one of those curves was one of these functions, x squared, or shifted up 2, or shifted down 3, and it should be pretty clear once you realize that the derivative of each one of those is 2x, because the derivative of the constant is 0. So the answer is the vertical shift doesn't affect the derivative. Alright, so that's going to be a key concept for the inverse process of the derivative. We call that the antiderivative. So on the left we have some very simple derivatives that everyone knows. The derivative of x squared, x cubed, x to the fourth. We're just using the power rule. There's nothing special about that. To undo this process, we use the antiderivative. So if the answer to the derivative problem is 2x, then the given function in the antiderivative problem is going to be 2x. Notice that we have this dx here in the denominator. We're going to put the dx in the numerator, and instead of taking the derivative, we take the antiderivative. Now the antiderivative is this funny S shape. So we're going to say that's the antiderivative of 2x with respect to x, or just 2x dx. And we know, based on this equation over here, that the answer must be x squared, because the derivative of x squared is 2x. But wait, it could be x squared plus 2, or x squared minus 3, or any other vertical shift. So for these answers, for these antiderivatives, we always include a plus, a capital C. That C stands for any constant. Again, that constant, that vertical shift, is not going to affect the derivative, so we, generally speaking, won't know what that C value is. So we would write for this one, we would say the antiderivative of, well, the derivative is 3x squared. So the antiderivative of 3x squared dx is going to give us x cubed, again, plus C. And the antiderivative of 4x cubed dx is going to give us x to the fourth, again, plus C. Alright, so those are some pretty easy ones. Let's see if we can try some slightly harder ones. Very slightly harder ones. So we want the answer to our derivative to be x. So we must have started off with x squared. But we would get 2x if we took the derivative of x squared. So we have to get rid of that 2. And we would just put a 1/2 there, so that we would multiply the 1/2 times the 2. And that would take us to the proper derivative of x. The derivative of 1/2 x squared is x. Don't forget, for all of these antiderivatives, we want to include the constant of integration. For x squared, we must have started off with x cubed, because the power rule will bring that exponent down by 1. But we don't want 3x squared, we just want 1x squared. So we're better divide by 3, so that the 3 times 1/3 will turn into the coefficient of 1 that we're looking for. And again, we always have that plus C. And one more time, we've got x to the third was the answer. So x to the fourth better be what we started with. But we don't want that 4 to stick around because we want a coefficient of 1 here. So we'd better put a 1/4 so that the 4 times 1/4 cancels out. And again, we have that plus C for our constant of integration. So this is the inverse power rule. The inverse power rule is very much like the power rule, except instead of dropping the exponent by 1, we increase the exponent by 1. So that's n plus 1. And instead of multiplying by the old exponent, we're going to divide by the new exponent. Everything gets flipped around because we're going backwards. And again, as always, when we take the antiderivative of anything, we have to include that constant of integration. So you're going to want to know this. This is going to be a fairly essential rule for you to follow when you're doing your antiderivatives. Alright, so let's take a look at some examples. They might not look exactly like x to the n, but we've seen problems like this before, and probably the first thing we would do is we would rewrite this as x to the n, right? 1 over x cubed is the same thing as x raised to the negative third. So our n value is negative 3. So we're just going to bump that up by 1. We're going to take negative 3 plus 1 and get negative 2. That's our new exponent, so we're going to divide by our new exponent, and we're going to say plus c. That is our answer. We would probably write that in a simplified form by dropping the x to the negative 2 into the denominator, along with the 2 that's already there, so 2x squared plus c. And you can always check these by taking the derivative of your answer, and it should take you back to this original function right here. It's called the integrand. The derivative of negative 1 over 2x squared should give you positive 1 over x to the third. And each one of these is going to work pretty much the same way. We are going to bump that exponent up by 1. That 3 was just part of the problem. It's a coefficient that sticks around. And our new exponent of 7 is also what we divide by. And really, that's it. It's as simple as that. So when we look at this, we might say, oh, we got to use the quotient rule, but we know better than that. First of all, there is no inverse quotient rule that we know. Second of all, quotient rule is overkill in a problem like this, because we have seen that we can just rewrite this as 4x to the 5th over x cubed plus 3x to the 3rd over x cubed minus 2x over x cubed, and that whole thing is going to be anti-differentiated. So when we try that, we're going to see that, well, each one of these reduces fairly nicely. 4x squared plus 3 minus 2x to the negative 2 dx. All right, so we're going to bump this 2 up to a 3. Our coefficient of 4 is still there, and we divide by our new exponent. This 3 doesn't go away. Constants go away when you differentiate, but not when you anti-differentiate. This is x to the 0, right? So we're just going to use that inverse power rule, and we're going to bump that up by 1. So we're going to get to the first power divided by 1, or just 3x. And then we're going to have one more problem here. We're going to have minus. We're going to have 2x to the negative 1, and we're going to divide that by negative 1. And never forget your plus c. So we end up with, let's see, we've got 4/3 x cubed plus 3x plus 2 over x plus c. Sounds like I've got to stop now. We'll pick this up later.